In this discussion, we talk about how PN junctions can be used in our day-to-day electronic appliances. We are familiar about the behavior a little bit by now. If they are forward biased, if the positive terminal of the dry cell is connected to the P side of the PN junction and the negative terminal of the dry cell is connected to the N side of the PN junction, it is forward biased. When forward biased, the electric current flows. When reverse biased, the electric current does not flow. The equipment, the electronic appliance made by using this technique is a PN junction diode. We represent it using several symbols. P and N, PN junction is represented like this, and the two conductors. The most commonly used symbol is this. The two conductors are represented in this manner. So, the head of this arrow, the arrowhead shows the direction of the electric current. So, it should be positive from this side and the negative terminal should be connected to the other side. We call them anode and cathode. Simply, this is how to draw the symbol of a PN junction diode. In the market, you can get those diodes depending on their voltages. For an example, the biasing voltage of a silicon diode, silicon PN junction diode is about 0.7 volts. The forward biasing voltage of a germanium PN junction diode is about 0.3 volts. Depending on your requirement, you can select many diodes from the market. The shops, those sell electronic appliances. Then we talk about using the diodes in our circuits. The first application, it is very useful. When using some toys, we know that we have to place the dry cells in order to make them work. For an example, I selected a remote controller. When you insert dry cells into this one, you have to correctly arrange them as the positive and negative terminals are not interchanged. Sometimes in earlier appliances, if you interchange the positive and negative terminals, those appliances may get burnt. But this can be done by using only one PN junction diode. Let's see how it happens. I select a very simple circuit in order to show you the application of a PN junction diode. If you study this one, the dry cell is over here, positive, negative. The dry cell is placed over here. If this circuit is arranged like this, the torch bulb or the electric bulb glows. If you interchange the positive and negative terminals, once again there's no problem, it glows. But if you use another circuit which is sensitive to the polarity of the dry cells, if positive and negative are interchanged, what will happen? You will lose the equipment that you have bought. In order to prevent that trouble, we use a PN junction diode like this. Let's see what happens. Positive, anode, positive, cathode. What will happen to the equipment? Does it work or not? Yes, it works because this is the forward biased condition. Forward biased condition. Positive terminal of the dry cell is connected to the positive terminal of the diode. Then the electric current flows and there's no other barrier there. It works. Let's see if accidentally, if you change the poles of the dry cell, negative terminal and positive terminal, negative terminal over here and the positive terminal below it. negative to positive. Does it conduct electric current? No, we have to follow the positive terminal. Yes, current, electric current. No, it is connected to the negative terminal. This is a reverse bias. Very simply, this equipment is safe. Safe from this accidental interchanging of poles of the dry cell. Before discussing about the next application, I would like to introduce you the two types of electric currents that we use in our day-to-day life. There are two types: electric current, DC and AC. DC, direct current. Let's see why it is called direct current. I use a very simple circuit once again. I consider the dry cell as the source of DC. Let's see why it is called a direct current. Positive, negative. The electric current flows from positive to negative terminals. Yes, of course. This is the direction of the electric current. I represent the direction of the electric current using an arrowhead. Positive to negative it flows. When the dry cell is fixed like this, does it ever change? No. Until the dry cell is totally discharged, the electric current flows in this direction, direct current. It has only one direction. If we use a graph to represent the direct current, voltage against time, one dry cell is 1.5 volts. It has a potential difference of 1.5 volts. If this is 1.5 volts, the direct current is always flowing in one direction. It looks like this. This is the graphical representation of the direct current. On the other hand, AC, its name is it is called as AC because it is alternating current. This alteration is the polarity. If you connect a source of alternating current into this between these terminals, the polarity always varies. At one moment this side can be the positive and the other side is the negative. At the other moment this side is negative, the other side is positive. The electric current flows in this order. Look at my finger. I represent the motion of the electric current. Here it is only one direction. This one, it flows alternatively. It changes the polarity always. If you want to show it in a graph, 1.5V, voltage against time. Yes, if it is 1.5 volts, it looks like this. It always varies the direction of the electric current. After getting an idea about the DC and AC, direct current and the alternating current, we talk about another application of PN junction diodes, that is rectification. Basically, rectification is, once again, it has two methods in it. One is half wave rectification. Half wave rectification. Basically, rectification is changing or converting. Converting what? You can convert alternating current into direct current using junction diodes. Let's see how it happens. I use this setup to explain how the rectification, half wave rectification, is done by a PN junction diode. First, 230 volts alternating current, that is the domestic supply, the domestic potential energy that comes through the electric supply of our national grid, and it is converted into 6 volts AC alternating current. 230 volts is converted into 6 volts. We call such equipment as step down transformers. We will talk about these step down transformers in our future lessons, electromagnetism and how they work. Until then, just imagine it converts 230 volts alternating current into 6 volts alternating current. But if I want a direct current, I have to get a graph like this. Simply, I did not label the axis of this graph, but I need a graph like this. What actually happens is this graph looks like this by now, because it is alternating current. Now look at this one. I have placed a PN junction diode over here, 6 volts AC. The first cycle, imagine that it is positive right here, and yes, positive is connected to the positive terminal, negative is connected to the negative terminal. The electric current flows for 1 millisecond, or maybe depending on the frequency of the electric current it varies. So the first cycle works. I make it darker. It can flow through the circuit because it is forward biased. Next instance, when the alternating current alternates its terminal, what happens to this side? It becomes a negative terminal. Now, does the electric current flow? Negative to positive. It is reverse biased. So, this part of the graph does not flow. It becomes 0. Once again, when this side becomes positive, another half wave can be made. What will happen next? Negative, positive. When it interchanges, only half of the wave can be taken. Look at the name. Half wave rectification. Only half of this full wave, total wave can be taken using one diode.